In this lecture, we are studying about a simple machine that is called as Atwood's machine. Or you can simply say pulley mass system. So this is a pulley over which a string is passing like this. And the two ends of string are attached with two masses. Let's say this is M1 and this one is M2. You can choose any one of the mass greater than the another one. So let's say I'm saying M2 is greater than M1. And right now I'm holding this string. So the masses are not able to move. But the moment the strings is free, it means I have removed the external force. So what happens? Mass M2 starts moving downward and M1 starts moving up. Now you must have imagined why it's happening. The masses are moving up and down because they are connected with each other. If you try to visualize the forces acting on the masses, then the forces acting on the masses are, first of all, for M2, the force is M2G. And because of this M2G, there is a tension which is produced in the string. Let's say that is T. On M1, there is a force M1G which is acting downward. And because of this M1G, there is a force upward in the string. And this force is nothing but the, again, tension in the string. The tension towards the left side will be is equal to tension towards the right side because the string is same, and here we are considering the pulley is frictionless. So there is no consideration of friction in this situation. Now to solve this Atwood machines problem further, what we need to visualize is the acceleration of the two masses. So the acceleration of the two masses we can take as A because two masses are attached with each other. So whatever is the acceleration of M2, same will be the acceleration of M1 and vice versa. So let's say the acceleration of M2 is A, which will be downward because M1 is moving downward, because M2 is moving downward. So the acceleration of M1 will also be A, but the direction would be different. Now in case of M1, the acceleration is A. Let us now draw the free body diagram to find out the tension and the acceleration of the masses M1 and M2. And in case of free body diagram, first of all, we have to visualize all the forces acting on the masses M1 and M2, and later on we have to treat them as an independent system. So here M1 is now one independent system on which the tension is acting upward and M1G is acting downward. Since mass M1 is moving up, it shows that tension T is greater than M1G. And if this is the situation, it means there is F net. So F net on M1 could be written as T minus M1G. Similarly, now if we try to draw the free body diagram for M2, so we can do it like this. First of all, M2G is downward, then the tension is up. This is tension. Since M2 is moving down with acceleration A, this is mass M2, it's moving downward with acceleration A. It means M2G is greater than T. In that case, the net force which is acting on the M2 could be written as F net. And let me just write 2 here so that we can say this is the F net on mass 2. Could be written as M2G minus T. Right? Mass F net is actually force acting on mass M2, and to find the F net we can write M2A is equal to M2G minus T. Let's make it our equation number 1. Similarly, we can write an equation for the second situation. And what is that situation? We can write the M1A, which is actually net acceleration, is equal to T minus M1G. This is, let's say, our equation number 2. Once we get the equation 1 and equation 2, we can use the simultaneous equation. So here I'm writing by using simultaneous equation, we can write M2A is equal to M2G minus, I can take the value of T from this place. Let's move minus M1G towards the left side. Then what we will get, in place of T we can substitute M1A plus M1G. Now if you simplify this, you will get the following relation. So now if we rearrange these terms, what we get here, M2A is equal to M2G minus M1A minus M1G. Let's move this, let's move M1A towards the left side. Then what we will get M2A plus M1A is equal to M2G minus M1G. And that's it. Here we can get the acceleration A is equal to M2 minus M1, G common, and we can write M2 plus M1. So the acceleration could be given as A is equal to M2 minus M1 G by M2 plus M1. Now to find the tension, you can put this value of A in any one of these equations 1 or equation 2 and we will get the answer. Right? So I'm leaving it to you to find the value of tension.